Miss Amy's Math.
If you were asked to graph this equation, you could use the point plotting method. But today we're going to learn another method. In this lesson, we're going to identify the parent function, any horizontal and vertical shifts, and then we're going to use that information to graph the equation. The parent function of an equation provides the starting points and shape of our graph. So for example 1, we'll identify the parent function in each equation. Let's look at equation A. If we cover up any numbers being multiplied, added, or subtracted, we're left with y equals x cubed. So that's our parent function. For equation B, we'll do the same thing. Let's cover up the numbers being added and subtracted. We're left with the square root of x, so that's our parent function. For example 2, let's identify the horizontal shifts. We'll be looking for a number that's with the x, being added or subtracted. It's often considered to be on the inside of the function. The horizontal shift will move the graph left or right in the opposite direction of its sign. This means that addition moves the graph to the left and subtraction moves the graph to the right. Now let's find the horizontal shift in example 2a. We're looking for a number that's on the inside of the function that's being added to or subtracted from the x. Here we have 5 that's being added, so our horizontal shift is 5 units to the left. Now again for equation B, we're looking for a number that's on the inside of the function or with the x that's being added or subtracted. Here we have a 2 that's being subtracted, so our horizontal shift is 2 units to the right. For example 3, we'll identify the vertical shift. For the vertical shift, we're looking for the number on the outside of the function that's being added or subtracted. The vertical shift will move the graph up or down in the same direction as the sign. This means that addition shifts the graph up while subtraction shifts the graph down. Okay, so for example 3a, let's identify the vertical shift. We're looking for a number that's on the outside of the function that's being added or subtracted. Here we're subtracting 1, so our vertical shift is 1 unit down. Again, for equation B, we're looking for the vertical shift. So we're looking for a number that's being added or subtracted on the outside of the function. Here we have a 4 that's being added, so our vertical shift is 4 units up. Alright, so we are ready to graph. The first thing we want to do in example 4 is identify the parent function and any horizontal and vertical shifts. So in equation A, we're going to cover up the number being subtracted, and we're left with y equals x cubed. So that's our parent function. Next, we'll look for any horizontal shifts. The number that's with the x is 2, and it's being subtracted. So that means our horizontal shift is going to be 2 units to the right. Since there's no number on the outside of the function that's being added or subtracted, we don't have a vertical shift for this function. So we start by graphing the parent function, y equals x cubed. Next, we'll apply the horizontal shift by moving all of the points on the parent graph 2 to the right. And we've graphed our function, y equals x minus 2 cubed. Now we want to graph equation b. So we start by identifying the parent function and any vertical and horizontal shifts. If we cover up the number being added, we're left with y equals the square root of x. So that's our parent function. Now since there's no number on the inside with the x that's being added or subtracted, we don't have a horizontal shift for this function. But if we look on the outside, we have a 3 that's being added. So our vertical shift will be 3 units up. So we start by graphing our parent function, y equals the square root of x. Since there's no horizontal shift, we'll move on to apply the vertical shift. Every point on the parent function gets shifted up 3 units. And we have our graph, y equals the square root of x plus 3. Alright, so for our last example, we want to graph the function y equals the absolute value of x plus 2 minus 4. Again, we start by identifying the parent function and any horizontal and vertical shifts. So if we cover up the numbers being added and subtracted, we're left with y equals the absolute value of x. And that's our parent function. Next, we look for a number that's with the x being added or subtracted. Here we have a 2 that's being added. So our horizontal shift will be 2 units to the left. Now we look on the outside of the function. We have a 4 that's being subtracted. So our vertical shift will be 4 units down. So we start by graphing our parent function, y equals the absolute value of x. Next, we'll apply the horizontal shift. So all of the points on this graph get shifted 2 units to the left. Now we can apply our vertical shift. All of the points on this graph get shifted down 4 units. And we have our graph. Y equals the absolute value of x plus 2 minus 4. And that's it for today's lesson. Next time we'll be discussing reflections, vertical stretches, and vertical compressions. If this video helped you in any way, give it a like or let me know in the comments.